Okay, so good evening.
So
Yeah, good evening. So Udit, kindly mute your this microphone.
yes, yes. Sorry.
Yeah, yeah. So we are discussing this year's electrical engineering optional paper of UPSC mains examination, and probably I will discuss only paper one because it will take a lot of time to discuss both paper. So first I will try to complete the first paper, and if time permits, then we will go for second paper. Or otherwise, in other scenario, we will discuss the second paper separately. So let's start with the first question, and if the discussion regarding the option selection, that we will take after a while. After discussing this paper, we will take which questions were easy and which were difficult. First, we will try to solve all questions one by one. I will just give you a hint. I will not. I am not going to solve each and every question. And ultimately, as you will realize, I am also a learner. Although I have given 5 attempts with electrical engineering optional in mains examination, but it has been a continuous learning process, and still I am not sure about many topics from the syllabus. So wherever there is difficulty, I will means I am quite frank about it that there are some questions which I found difficult and which will require a discussion. And if there is some contribution from your side, then that will be even better. And after discussing this paper, we will then form a small group of like-minded people, and we will divide the work, and we will have discussion on topic wise discussion from the syllabus, probably on 3-4 days, and we will create a feedback mechanism. I'm kind of thinking we should do this because electrical engineering optional people, there are very few people, and hardly 60-70 people are writing this examination, and everybody is working in isolation. If you are doing some other exam, then that is different. But if as far as my case is concerned, I am working in Coal India since last 10 years, and since last 10 years I am living means there is no aspirant for the people, the kind of environment which we look for while preparing for the examination. We don't have such kind of environment anyway. So let's start with the first question. The first question here, yes, it is available on the screen. A two-port network is given, and it is written that it is characterized in terms of bi-parameters, and they have given the bi-parameters by 1 1 by 1 2 2 by 1 2 by 2 1, and then they are asking to find the voltage across 200 ohm load. So actually what we can do here in this question, we can write the equivalent bi-parameter, means equivalent network of a bi-parameter. So we know it that equivalent network for reciprocal network. If we have the reciprocal network, then from bi-parameter we can make a equivalent pi network. So we can make like this, a network like this will be equivalent. So this here it will be this element will be by 1 1 plus by 1 2. This will be by 1 2 minus, and this will be by 2 2 plus by 1 2. So here they have given that by 1 2 and by 2 1 both are by 1 2 and by 2 1 both are equal to 0. It means it is an open circuit. Let us draw the equivalent, and then let us draw the complete circuit. Let's find 2t. Okay, so we will the here I am doing is open. So I am just showing it by this. This 200 ohm load. It would be better if we convert it into equivalent impedance. So it will be by one divided by y11 plus y12, and it will be by 22 plus y12. So y12 is obviously 0. So now we require to find the voltage across 200 ohm resistance across 200 ohm load. Now this problem is quite easy. You can apply the phasor. So let us write the equivalent phasor diagram. Circuit. So here we can take 100 at the angle 0. Henry it is given. So equivalently the impedance will be j omega L, if you know. So omega here is 2. 2 cross 2 is 4. So 4 at the angle of 90 degree. This will be equivalent impedance here. And I would ask you to find out this 1 divided by y11. And this is given impedance only. This is impedance. And here this capacitance is given, so 1 upon 0.01 into omega is 2 at the angle of minus 90 degree. And on this side, again you can find out, and this is 200 ohm. Now you need to apply the KVL, I1 and I2. Apply KVL and solve I1 and I2. And after solving this, you can find out the voltage across 200 ohm load. F V out at 200 ohm is equal to I2 into 200. So this will be the voltage. I am not solving it fully because I don't have I forgot to take the calculator, and if we go in solving each and every problem, then it will take a lot of time. So I have given you a brief sketch how to approach this problem. And now let's go to the problem number 1B. Problem number 1B, yeah. This problem, they have this type of questions they are asking every year. If you go in 2017, 18, 19, for every year they are asking such kind of questions for 10 marks, and it is very easy question. So here they have written that for the signal it is shown here. First they are asking us to find the total energy of the signal xt, and then they are asking us to sketch the signal by t is equal to x of 10t minus 5. It is very easy question. And like previous question, I am not going to solve it, but I will give you a brief idea. 1B. So the energy, as we know, energy of a signal is E is equal to minus infinity to infinity xt square dt. So we need to just integrate the signal. So first we need to find this signal, and then this signal, then this signal, and then this. So if we go like -3 to -2, the expression here will be t plus 3 perhaps. I'm not wrong. T plus 3. So at -3 is 0 and -2 it is 1. So t plus 3.
Hello.
Yeah. Hello.
Priyank can't we do that this problem like it is a even function x of t is equal to x of minus t equal to x of t. It is even function. So can't we
Right.
do directly two times of 0 to infinity x of t square dt?
Yes, we can do. We can do. So we in that case we will we can do that. Yeah, you are right. We can
Just
take from
define
zero. Yeah,
here given x
0.
of t is even function and
Yeah,
directly
yeah.
2 times of 0 to infinity.
0 to, yeah, to 0 to infinity. Yeah, so we can do that.
Okay, okay.
We can do it. Actually, that will save our time as well if while doing that. So we can do that. So this will be the our energy. And after finding energy, we need to sketch by T is equal to x of 10T minus 5. So x of 10T is actually your compression. First, let's do x of 10T. So x of 10T would be like this. Minus 1 to 1. So you write here minus 1 upon 10 to 1 upon 10. Okay, sorry. It's okay. It's 2. So minus 1 upon 10 to 1 upon 10. Then this is 2 upon 10. This is 3 upon 10. Right? And here also we need to do minus 2 upon 10. And this is minus 3 upon 10. So this will be x of 10T. Now we need to shift the signal into toward the right. So we will do means if the 0 point has to be shifted toward the right side. And so after shifting, it will the whole signal will go here at 5, and we need to sketch at 5. This is very easy. They are giving 10 marker for it. The third question, now I'm coming to third question. The third question is also very easy from DC shunt motor. The question has come from DC shunt motor. First of C.
Priyank
Yeah.
Yeah, I have a
Please.
doubt. You solved that question. First, you did scaling and then shifting.
Yeah.
Don't you think that there is a right sequence of doing? First, we have to do shifting and then scaling and then reversal. Then only this signal will be correctly correctly sketch will be there. Otherwise, if it is there in this way, like x of 10 is out and t minus 5 by 2, 5 by 10, yani t minus half.
Okay, you mean to say that x of 10 let's
And
take
t
out
minus
5.
10 out and t minus half.
Okay.
In this case, you have to apply first scaling,
Okay.
then shifting and then reversal. First scaling, then reversal and then shifting. Otherwise, if it is given directly 10t minus 5, then you have to first apply shifting property. It is right shift, and then
Okay.
scaling and then reversal.
Okay.
First we have applied
Reversal is
first.
perhaps not required here.
Here reversal is not given, actually not required here. Okay, but
Yeah.
in this case we have to first shift the signal by right by 5, and
Right
then
by
5, and
half.
then no 5. No. Given in given problem is it is given x 10 t minus 5. So first we have to shift t by 5 right shift, and then
Actually,
apply scaling.
if you
If
can,
if it is given like this, wrote this x of 10 bracket t minus 5 by 10. Then we have to apply first scaling and then shift.
okay, first,
Rajendra is
okay,
right.
yeah, you are right. So first, the shifting has to be done. So we will do by 1 by 2. We will shift to right, and then we will do the scaling. This is what you mean.
No. In this case, we have to first do scaling by 10 and then right shift by half. And the first given in the given actual problem, we have to first we have to do first shifting and then scaling. If I am
Oh,
not wrong.
okay,
Actually, in the form in which the question it is mentioned that x of 10t minus 5. If we write in that if we retain in that same form, then we will have to do shifting first by 5. We'll shift to
Ha.
the right, and then we will divide
Okay.
all the x-axis by 10.
By 10. Yeah, right.
Hmm.
We cannot do first scaling and then shifting in given problem.
Right. Okay. So we
There is an order of carrying out those expression, doing the transformation. There is an order, precedence that has
right,
to be followed.
right. Okay. So we will first do the shifting, then we will do the scaling. Right.
Yeah.
Right. So it's a good input. Now coming to the question 1C. DC motor here, it is given, the DC shunt motor is given, and it is given that it is having an armature resistance of 0.13, field resistance of 250 ohm, and rotational loss of 230 watt. And on full load, the line current is 9.5 ampere, and motor is running at 440 RPM. So they are asking us to determine the mechanical power developed. So let's first make the DC shunt motor. So at rated condition, I am making array. This is its back EMF, and this is RF field, and 220 volt. RA is 0.13 ohm. RF is 250 ohm. And the rotational loss, it is written there 230 watt. Now, on full load condition, the line current is 9.5 ampere. So line current, it is written, so this current is 9.5 ampere. And motor is running at 40 RPM. So they are asking us to determine the mechanical power developed. So let us first find the back EMF at this condition. So 9.5 ampere, it is written that line current. So what will be the field current? The field current will be 220 divided by RF. So RF is 250. So the armature current will be, IA will be 9.5 minus IF. Now it is, the question is now we will find the EV, the back EMF. This condition, full load condition, the back EMF will be 20 minus IA into RA. The back EMF here, this is equal to, let us take EB is equal to IF omega m. And we have found the value of back EMF from this. So we can write is equal to K. If we know that is, we know this value, and omega m is also given 1440 RPM. So we can write 1440 divided by 60 into 2 pi. Now from this we can find out the value of K. Back EMF KB, we can write it KB. First question is, they are asking us to determine the mechanical power developed. So the mechanical power, the power developed will be the power developed will be V into IA. So this will be the mechanical power developed. We have found the EV, we have found the IA, so this is mechanical power developed from this. Second part is power output. So the power output would be we have to minus this rotational loss from mechanical power developed. So power output would be equal to mechanical power developed minus 30 watt. The third is the load torque. So the load torque will be mechanical power developed. Okay, so the load torque, it is saying, so the load torque will be the power output divided by RPM. RPM means RPM into 2 pi upon 60. The fourth is the full load efficiency. Full load efficiency will be the power output divided by input. So input is 220 into 9.5 ampere. So I hope this is correct.
Yeah, it is okay. Correct.
Yeah.
But why you're finding value of KB? It's not required, I guess.
It is not required, right?
Got it.
Okay, so the fourth question, the fourth question of first is for the transistor shown in the figure, determine the value of reverse saturation current IF that would give a collector current of 1 milliampere. Beta is 80 and VT is equal to 26 millivolt. So they are asking us to find out the reverse saturation current that would give a collector current of this value. So solving it. One D. The basic relation we know is that IC is equal to IS e raised to the power BVE upon VT. BV is base emitter voltage. And here we have to solve the circuit as well. So they are saying that find the value of reverse saturation current. Find this IS for the value of IC given, but we require to find VVE. So VVE we will find from the circuit. We can write this base voltage and emitter voltage. So, okay. So here beta value is given and we can use this beta value to find this. So collector current is written here. The collector current we want 1 milliampere. So collector current is 1 milliampere. Accordingly, this base current will be IB IC upon beta. So we can find this base current. This base current and consequently we can also find this emitter current also. And from this value we can this is collector current. Okay, this is PNP. So this is collector current, and this is base current, and this is emitter current. And this IC, and then we can find this value of current. And accordingly, if we are able to find this value of current, then we can find this voltage. This voltage will be our collector voltage, and from this we can find also this value, this VV. We know VE is 2.5 volt because it's PNP, and from this VV and VE we can find VVE, and we can we can put this value of VV in this equation to find out the reverse saturation current. Right.
Yes.
Okay, so the fifth question is it is written that 4 variable logic function they have given, and they are asking us to propose a logic circuit using 3 logic gates to implement the function. So they are asking us to write it in 3 logic gates. So we can go for SOP, sum of product implementation of this circuit using K-map, and and by reducing it through K-map, we can find its implementation. Shall I go for writing all that K-map, or I may leave it?
I think not required.
Not required, right? So approach is okay, or we can improvise it. Means what I think you can means. Is it good, or we can go for reduction? Means algebra, Boolean means this algebra would be better.
Yeah, I think without K-map also we can solve this.
Okay, from yeah, through K-map. I actually an actual exam I did through K-map. Okay, so
Okay, then you can do with K-map also. Then whatever is comfortable for you, you can.
yeah, right. Now coming to the question 2. Question number 2, and in question number 2, first question they are asking us to find the Thevenin equivalent of circuit across the load impedance ZL, and they are also asking us to find the value of ZL for maximum power transfer. So this is comparatively easy question. For left first so let's first do first find this the Thevenin voltage across ZL, and then we will find the value of ZL. It's the Thevenin impedance. So Thevenin voltage across ZL would be like we will keep it open circuited, and then we will apply the KVL. So let the current be I1 here. Here let the current be I2. So obviously I2 will be 0. This will be our Thevenin voltage. So let's write KVL here in first loop. So 100 at the angle of 0 equal to I1 of J2 here J4 plus J4 2 plus J3, and I2 is actually 0. So here let us find this M also. So M will be equal to K upon under root L1 into L2. It's okay. This formula is okay. M is equal to K upon under root L1 upon L2.
I think it is M is equal to K into root of L1 L2.
Yeah, it is K into root of L1 into L2.
Right.
Because
right.
K is
right.
K is actually the ratio, on
Yeah.
root L1
Yeah.
L2.
Yeah. So then first this loop do not require the means I2 if I2 is 0, so M cross 0, and the second loop 0 is equal to I2 is 0, so 0 cross this plus we need to incorporate this M cross 1, right? No, that will also go 0. So only one loop we require.
We have to just need one loop. I1
Yeah,
we will
yeah,
find
yeah.
by this phasor
By
method.
yeah. We will find this I1, And after finding this I1, we will find this VThevenin across these two terminals. Right. So actually, this voltage will be actually the voltage across these two terminals.
Across 2 plus J3.
But we need to incorporate this thing also, this M thing.
Yes, I think it should come.
Yeah. So
MDI.
so this VThevenin will be equal to I1 cross 2 plus J3 plus M
Plus
cross
M
I1.
JMI1.
M cross I1 for this, for accounting for this, because it is linked mutually, means there is mutual coupling between this and this, so we require to include this in M. So this will be our VThevenin. And the second part of it is that we require to find this.
I think it has to be M into I2.
But I2 is 0.
It will be JNI1, not I2 0.
Yeah, JN, right. This question took a lot of time. In my actual exam, I gave around 20 minutes to this question. Okay, so now
Priyank ji,
yeah,
can't we do this question like first convert this mutually adding circuit into equivalent pi circuit?
okay,
Like calculating first calculate mutual inductance M is equal to K root L1 L2,
right,
and after that simply converting this mutual adding circuit into L1 minus M, L2 minus M, and in between mutual inductance plus M. If we consider mutually adding, both currents are entering,
okay,
and then simply it will be like a 100 volt, 100 at angle 0 minus J2, and L1 minus M, in between plus M plus Jm, and 2 plus J3, and in this that side L2 plus M, L2 minus M, and I2 entering and I2 0, that it will be easy for calculating equivalent impedance ZL, Thevenin impedance, as well as open circuit voltage VOC, yeah,
okay.
Thevenin voltage.
I am reproducing here what you are saying. He is saying this. We can do like
Will
this.
be
L1
converted in T shape. Star.
And
So this is what
we
you are
don't
saying.
yeah, L1 it will be L1 minus M
Okay, L1
and
minus
L2
M.
minus M.
Okay,
L1 minus M. M we will calculate by using M equal to K root L1 L2.
right.
And then below circuit will be 2 plus J3, right?
Yeah. So this would be like this.
Yeah.
So this would be easier for us then.
Then simply apply KVL and we can calculate it. And by doing open circuit, we can calculate also short circuit voltage circuit. We can calculate ZL,
Yeah.
JTH, and by simply opening the load resistance ZL, load impedance ZL, will calculate VOC
Yeah, actually
by
this
calculating
approach,
I2.
yeah. So this approach will
There will be no confusion actually.
right. There will not be any confusion.
Yes. This is fine. This one is better.
This one is better, right. So this will be better approach. Okay, so then I think I am not required to solve it fully then, because it has become very easy now to do it. Only KVL is required in two circuits. Okay, so now coming to the question number 2B.
Excuse me, sir.
Right. Yeah.
Sir, can you solve that digital electronic question, that previous one?
Digital electronics question. Okay. So you are saying this question.
Using K-map, you said that.
Okay.
Because they are saying that with 3 logic gates we have to do.
Yeah, actually, in 3 logic gates, it is not happening. Actually, one AND gate is still required, right? You must be saying that.
Yeah,
Have
I
you
just want
have
to
you
know.
have you solved it or not?
Yeah, I solved it, but I want to see how you're doing with K-map. You said you
Okay.
did with K-map, right?
Yeah. Actually, one and not gate is still required here. All otherwise, if okay, one AND gate is required.
Okay.
If three NAND and one AND, or 4 NAND, you may say that. So then that way I bent. A bar C. Right. D. B bar C. B bar D. A B C bar. So we have I don't think it will be. It is going to. Audible.
Yeah, actually.
Yeah.
I think it is complex.
I don't think now it is going to solve. Actually, I think I have made a mistake in actual exam. I have not drawn properly the K map.
Okay.
It seems so because now I don't think it will be. It is going to get solved in 3 logic gates.
Mhm.
Will require at least 1, 2. Or it will not solve. So then we require to go for the Boolean algebra. So let's try to solve it through Boolean algebra. Input. We need to say it later on. Actually, I don't think I can. It require reduction. Okay, we will come back to it later on. Let's leave it here.
Okay, okay.
Now let's come to question number 2B. The question number 2B, the first part is they are asking us to find the convolution between these two. So what I have done, I have calculated the Z transform of both, and then I have reduced by finding out the inverse Z transform. The other method may be that you go for direct convolution finding, be finding out the directly the convolution from these two. But I was finding that finding direct convolution, I was finding a little bit difficult, so I went for finding out the Z transform and then taking the inverse Z transform. So here Z transform of xn is equal to 2 raised to the power n u of minus n minus 2. So we know a raised to the power n minus a raised to the power n u of minus n minus 1. We know the Z transform is 1 upon 1 minus a Z inverse. That is less than a, means this is its region of convergence. Here, and we also know that x of n minus 1 is equal to Z inverse xz. Accordingly, we can find out this xz is equal to minus 1 upon 2 raised to the power Z inverse into Z inverse. Okay. Now, let us find this hn. So hn is h of u of n minus 2. So here also we will do the same. A raised to the power n u of n is equal to 1 upon 1 minus a z inverse. So here 1 raised to the power n we are taking. And then we will do the delay. So h of z is equal to z2, z raised to the power minus 2 upon 1 minus z inverse. Now let's find out the by z is equal to xz into z is equal to minus z inverse upon 1 minus 2 z inverse to z raised to power minus 2 upon 1 minus z inverse. Now we have to find out the partial fraction. And after finding out the partial fraction, we will take the inverse Z transform such that the inverse Z transform will be such that we have we have these two terms in the response, this term and this term, and that will be the response. So do I require to find out the inverse means the partial fraction also, or shall I leave it?
You
Leave
can
it.
leave it.
So the approach is okay, or we can do means there can be other approach as well.
I think for this graphical representation is good,
Okay, so
and we
going
can solve also using Z transform also.
right. Actually, I was also thinking because in earlier years also many questions have come, similar questions have come where they have solved. They would have been better if we go by finding out by means directly by graphical method. In
Yeah,
actual
because
example,
in the using graphical representation, I think we have to define n limits also for n less than 0 Z function, and for n greater than 0. Like this, we have to solve this question.
right.
Graphical will be, I think, more complicated. Z
Actually,
transform
yeah,
is easier.
More complicated, but we in this also it is okay. But then we also find out ROC means region of convergence. We have to keep in that mind how to define limits.
Uh-huh.
yeah. So this question was for 10 marks for F. Yeah, for 10 marks, this question was.
Yeah.
Rajendra, if you have solved this, can you send the solution? Or
Mm, after forming the group, I will solve. I will send. Actually, I have solved this paper, but not completely. But I tried.
okay.
So after discussion, we will form a small group. Means 4-5 people
Due
are
to
there. Yeah.
prelims CSET paper I couldn't clear this time, so I can't. Okay.
Okay. So now let's go to the second part. The second part of B question. Okay. Let's go. Okay. So let's go to the part 2 of the second question. Here the signal xt is given and they are saying it to represent xt in terms of rectangular pulse vt. So they are asking us to write it in form of this. This is very easy question, right? Like we have to just shift this and multiply it. So we can write like xt is equal to
Priyank, I have shared the 1E answer. Can you check it in the chat?
1a.
E.
1e.
The KMF bolo question. Yeah, KMF question.
Right. Okay. You have gone 1e. So you have skipped some steps, right?
No, most of the steps are clear in this only.
Okay, so you have first taken the double means.
Okay. So basically, for the first two terms, I've taken
Yeah.
A bar out and C plus D in the bracket, and for the second term, B bar out and the C plus D in the bracket.
Right.
And that's why it formed like this way.
Right. Okay, so this is very easy then. Yeah.
Hmm.
Okay, so I think others also can see it. So by going through this, it is very easy. I did through KMap, and actually through KMap it was not possible to do it.
Yeah. I did the same thing. Then I went to this method and then I corrected myself. That's why it took me a lot of time to solve this question.
Right. Okay, so you were also writing this year's mains exam.
Yeah.
Okay. Yeah. Actually, this such kind of questions are coming every year. In 2017, also some similar questions came, and means I have I have a tendency to solve such kind of questions through KMap. But generally, these questions are not getting solved by KMap.
So this was like because they limited the gates, that's why it became complicated. Otherwise, it was a
Right.
simple question.
Right. Okay, so now the 2B is very easy. I think means we just require to write xt in terms of vt. So the xt will be equal to means vt minus 1 of vt minus t upon 2. Okay, this will require means it will not be like this. V minus 0.5 divided by 2, if I am not wrong. From here to here we have 1. Here to here we have 1 plus v minus, we have to shift here at the center, so it will be 3.5 divided by 2. Multiplied by 2. It's okay.
Priyank,
Yeah.
in exam also we can write like this also, like that,
Actually,
like directly,
no, it's actually
or
10
other,
marker.
or else.
Actually, if 10 marker question, so we need to show each step, means VT minus 1, VT minus 2, like that. But is it okay? Means is
Uh,
okay, so we do not require 2 here. Already there. Other approach may be that B shift it's to means 2. So like okay, so let's do it again. So we can do, actually that will be easier. B xt is equal to, first shift this to here. So we will find this term, center term.
I think it will be Vt minus 1 plus Vt minus 2 plus 2 of Vt minus 3.
Vt minus 2, if we go into 2. So we have completed this, and then we will add Vt minus 0.5 divided by 2. So this upper term is taken. Now we have to take the first and this. So this will be, the first will be T minus 0.5 divided by 2, and the last will be 2 into Vt minus 3.5 divided by 2. So is it okay? If I have taken the center, the first this term, I have completed this term by shifting it here, multiplying it by 2, and then
Priyank,
yeah.
hello. I think in this there will be no term like this, t minus 2.5, t minus 3.5. First we
It's
have to
coming
write
like
x of t in terms of u of t. First we have to write x of t in terms of u of t, and then v of t in terms of u of t, and just shifting v of t by 1, 2 and 3 respectively, and by adding these three terms we will get x of t.
Rajendra ji, is this are you getting this one? Vt minus 1 plus Vt minus 2 plus 2 Vt minus 3.
We can go, yeah, xt is equal to Vt minus 1. Yeah.
There
Plus
will be no scaling on t, like you have written like v of t by 2 minus 3 minus 3.5 by 2.
so somebody was suggesting me, somebody was writing Vt minus 1, Vt minus 2, so we complete here till here. But how to take this term? This means this upper term.
No,
without
just first write x of t in terms of u of t. Like x of t is equal here in this case x of t will be 1 second. X, like in this case x of t will be u of t plus 2 into u of t minus 1 plus 3 into u of t minus 2 minus 2 into u of t minus 3 minus uh, 2 into u of t minus 4. This will be x of t in
Right.
terms of u of t. Now you write v of t in terms of u of t. That will be u of t minus 1, t plus 1 minus u of t minus 1. Now apply shifting property on v of t. Like first shift by 1. You will get u of t minus u of t minus t. T minus 2 and then again shift by 1, then we will get a v of t minus 2 is equal to u of t minus 1 minus u of t minus 3 again by 2, then you will get a v of t minus 2 is equal to u of t minus 2 minus u of t minus 4. Now multiply by 2, I think equation second equation, and then add these three equations. You will get x of t directly in terms of v of t.
But okay, that is okay, but that will increase difficulty a lot. Means Odit is suggesting something. I am writing that only. V of t minus 1 plus v of t minus 2. He is writing 2 of v of t minus 3, right? Isn't it?
Yeah. We can write.
Yeah.
Yeah.
But
So
actually, this is a 20 marker question, and like when solving it, arriving at this, so I just saw it, and then like just within the mind only I got this answer. But for solving it,
Yeah.
so we need something now.
But we
right.
have to write in language.
Yeah, we have to
Yeah.
write it in language. Like how have we arrived at this expression?
Yeah.
So I think, but this Rajendra ji, he suggested that UT expressing both of them in terms of UT and then manipulating to get that XT in terms of VT. So I
Yeah.
think it would be better if he can, if someone, yeah, he can solve, like if he can put it on paper and then send so that we can get that, because right now, so in verbally, it's getting difficult to understand. We can try it, but yeah, it will be better.
Yeah. So I would request Rajendra ji if after this class he can share this question. Means his approach. Actually, it's 10 markers.
I will share.
Yeah. Yeah. This question I
Sure.
am not
10.
able to solve. This 2C. What they are means they
By
are
the way,
asking.
this question is 10 markers, it's not 20 markers. So you do
Yeah, it's
not
10
need
markers.
to, yeah.
Yeah,
And
it's
generally
10
in
marker.
civil
Actually, there are
services
two parts.
questions,
Yeah.
generally in civil services, they will give simple questions. Only you need to be able to, only it needs to be clicked at that point of time. So even if it looks simple, you can even write that way also. Otherwise, simply you can write VT minus 1, you can show the shifted VT curve. Then VT minus 2, you can show the shifted VT curve by 2. And then you can show the shifted VT curve by 3. And then simply add them. That will give you the answer.
Right.
Yeah.
That because like
Yeah.
seeing 10 marker, it comes in the mind like we have to write some minimum words like in GS, but yeah, because I don't have any experience, so that's why I was asking like we have to do some big solution, or this was just like
No.
in mind only it came.
No. You don't need to do anything. It's just that whatever you have written, what you can do is the term that you have taken, draw its graph so that it will be more
Yeah.
visible. Otherwise, if
More
you have reached the
visible.
crux of this whole thing, like because that is the crux, it is the once you see the question, if you are able to understand that this is this easy, that then it also shows that you have the knowledge. Because somehow in the exam hall, it doesn't click so easily
Yeah, that
because
is
you are
true.
under a lot of pressure. So that is
Right.
fine
Hmm.
because there you will have to manage your time also. So do not go into that much detail.
Actually, yeah,
Okay,
it's right here. Okay,
got
so
it then.
yeah.
Next question.
Now let's come to this 2C. Actually, I am not able to solve this question and I have left this question. So if anybody can solve it, then it is better. If it is good, or we will skip it. Okay, so we are leaving it, and now we are going to the question number 3.1. And this question is also, the first part I am not able to actually understand what they are trying to say, because after okay, let me first read the question. The third A, and this the first part of third A. So if for 10 marks, they have given this circuit, and they are saying that explain what will happen when this circuit is constructed using logarithmic amplifier. So actually, what I understood, that they are saying that replace this Q1 by a diode, because that is the logarithmic amplifier. And replacing it by a diode will not actually change the functionality of circuit. It will be the same, because this is nothing but a diode. So this is what I understood from this question. If there is anything, any suggestion or any input, so we will discuss it. Otherwise, this is what I understood from this question. So a little detail but I can add is this. This is our logarithmic amplifier and B1. So this current and this current, I, this is same. So I is equal to V reference on R1 is equal to IF e raised to the power 0 minus V1 upon Vt. So this is logarithmic amplifier, and in this circuit also you will get the same thing. Okay, so shall we move to the next part of this question? Jendraji.
Yeah.
Yeah, actually, I am not able
It
to
is.
understand.
No. It is theory question. Just a derivation of logarithmic amplifier using transistor.
Right.
And
Means it is saying that what will happen, it will happen the same. Means the circuit is going to remain the same. Okay, so now coming to the part B of this question. Here they have changed this to this Q2. So actually in part 1, the IX is independent of this B reference. If we see, the IX is independent of B reference, because IX is okay. So let's do it. And the IX is equal to, the IX is collector current, is equal to IF e raised to the power BBE upon BT, and IF into e raised to the power BVE. So BVE is E1. Let us assume this VQ2, this value is VQ2. So VQ2 on VT. So this is independent of V reference.
It will be minus V1.
Pardon?
The value of VB will be minus V1.
Okay, value of VBE will be minus V1, right? Yeah. VQ2 minus B1. Okay, it is B1. No, it means where it will be minus. VB is this base voltage is V1 and this is VQ2. So I am saying
No,
this thing.
My bad. You are
actually
solving
the
third A. You are solving third A. I saw third B. Sorry, my bad. Sorry.
Okay. So this IX is independent of V reference in this part 1. However, in second part, this will not be so, because in part 2, IX is equal to this minus of this current value. Whatever it is flowing me, let us say I1. So this will be equal to minus V reference upon R1. So Ix will be equal to minus V reference upon R1 in the part 2. But in part 1, it is independent of V reference. So this is what I can think of this about this question. Shall we move to the next question?
Yes.
Yeah. So this part B of this third question, 3 of part B. In this question, similar question has come into 2019 also, where they have and circuit they asked us to find they were it was written cough of QT, and they were asking us to find the current value or some voltage value, and we required it to break it down and then apply the superposition. So here also we can apply the superposition, third of B. Here two voltage, one voltage source is given VT and the current source given IT, and they are asking us to find voltage V0t as a function of time. So the frequencies are different, 6 and 4. So we will apply the we will require to find two circuits. So let us first apply VT. In that case, we require to remove the IT. So we will write in form of phasor. So tan of angle 60 and tan ohm, and it require this value is required to be found out. So 1 upon 0.1 into 6 at angle of minus 90. IT we have removed. So and here it will be 4 cross omega is 6 at the angle of 90. It is 20 volt. We will find out this V0 using this. And this is part 1. Part 2 will be we'll sort this 10 ohm then we will find this V0 V02 from here, and from 1 and 2 we will add both. Right, so is it okay?
You,
With the 20
you are doing the superposition. You are applying
20 volt source
superposition theorem, and in that you cannot use two sources at a time, right?
Yeah.
Don't you think first we apply V of t using frequency 6 radian per second, and other sources remain dead? Like I of t is open circuit and 20 volt DC source is short circuit.
Okay, so you are
Yeah,
saying
I think we
okay,
should
so
do
you are
these
saying to
steps.
you are asking me to remove this as well, eh?
Yeah, and again I of t apply and V of t and 20 volt is shorted, and
Okay,
then
so
DC source 20 volt and I of t and V of t is shorted and open like this.
okay, actually we can do actually I have ignored this, means I have not taken this in superposition, so I don't think it will affect. Okay, you can
Because in first case also 20 volt sources came two times, I think.
Maybe we can, I think we can neglect the 20 volt source in the second part when we are taking the current source, DC source. Then we can neglect, maybe in to first one we can take both because they will
yeah.
be independent.
First one we can take both.
Yeah, I think in first one we can take both, but in the second one we'll have to remove because we have already accounted for
In
that.
second one we have to ignore V of t as well as 20 volt both, right?
Yes, yes, yes. Both will have to be shorted.
Yeah, because in this case in part one also 20 volt source came into picture, and in part two also 20 volt source came into picture. So it came two times.
But in superposition theorem, only one source is taken at a point of time. So
In superposition
if we
theorem we have
take,
to take one source at a
so if
time,
we
right?
take 20 volt, if we take 20 volt, then the answer will change, because in that case, the current through the 4 Henry inductance will be different, and that will affect the current through the capacitor also. So if we do not
Yeah.
take 20 volt, then 20 volt will be shorted. So in that case, the capacitor and inductor will be in parallel and some value of current will come through the capacitor. In the second case,
Yeah.
this 10 angle 60 degree will be shorted. So this capacitor and this 10 ohm resistor will be in parallel and accordingly the value will come. I think it will impact the answer. So someone will
Answer.
have to check
So we
like
have
how
to
is it impacting
we
the answer.
yeah we have to take, I think, one voltage, one source at a time.
Okay, so let us do three parts then. Means the part 3 we
Yeah.
will take
Okay.
exclusively and we will sort it here. Here also we will sort it, right? And part 3 we will take only 20 volt. So that will be easy then.
And what if we
Yeah,
do
that
the
would
nodal
be much
analysis
better.
in this case? Why cannot
We
the
can do
nodal
also
analysis?
nodal. Yeah, we can do nodal analysis also. But here we have DC sources as well as AC sources. And
And
for
also
that case, in that case, we have to apply superposition theorem.
frequency is also different. Otherwise, these components are not fixed. They will change with frequency.
Yeah,
Behave
yeah.
for different
That's
source
the
for
that's
different
the
frequency.
critical
Yeah.
thing. Yeah, I got
Uh,
it.
For,
Yeah.
for
Yeah,
different
superposition would be
frequencies,
the best
right
way.
one. Only that approach, yeah, best way.
Okay, so
Also, it's a
now
20 mark. So
this is 20
again,
mark question. Yeah. Actually, such similar
yeah, this
question
is
came in
20.
2019. 2019, a similar question came when they have written cough of QT. And they were asking us to find some voltage. So what we are required to do it, break it into cough of, it will break like cough of 2t plus cough of t, and then apply the superposition.
Got it.
Okay.
Yeah. So let's do now question number 3C. This question has come earlier also in perhaps in 2005. It is written, a mixer analog multiplier is used as a process in some analog communication systems. Two signals x1t and x2t are mixed to produce the output by t is equal to xt cross x1t cross x2t. If x1t is 10 sync 10t, x2t is 2 cos 1000 pi t, then calculate and plot the magnitude of Fourier transform of output signal. Further specify and prove the property of Fourier transform using the calculation. So simply, actually, what is required here is that we should remember the Fourier transform of this and this. Otherwise, finding out and then doing all that in 10 markers will take a lot of time. So this x1t, actually this the Fourier and the by t is written x1t cross x2t. Fourier transform of by of omega will be equal to x1 of omega convolution x2 of omega, right? So this is the property which is being used in the calculations. They are asking to specify and prove it. And the first part is that let us calculate the x1 of omega.
I think 1 by 2 pi will also be there. 1 by 2 pi into.
Okay, you are saying 1 by 2 pi. It will be there, right? Because I am taking omega. So with omega, it will be 1 by 2 pi as well.
Yes, it will be there.
Yeah. So x1 of omega will be equal to Fourier transform of 10 sinc t. So this will be a rectangular function like this. We can plot it directly by seeing. That will be better. I think it will be from 10 minus 10 to 10. And its value, I doubt whether it is 10 or it is not. We require to find it out. So the Fourier transform of x1 omega will be like this. x2 omega will be equal to, so it is easy, means 1000 minus 1000 pi, and here 2 j. This will be x2 omega, and then we require to calculate the convolution. So it will involve that integral, and I am leaving it because I generally avoid such kind of question which require these integrals and solving it. So because of that, I left it. But the approach will be like this. So if somebody can solve it, then please do it and write it in comment box. Okay, so shall I move to next question?
Sure.
So now let's discuss question number 4a. And it is written that a discrete time system with transfer function given by this. They are asking us to find the impulse response. So impulse response require simply we require to find the inverse Z transform. The first part is easy. Second and third part were difficult, and I had to leave these two parts. The first part left to the first part, and the second part is they are saying us to find the step response of the system with zero initial condition. So again, we require to find that inverse Z transform by doing that partial fraction. And the third part was even difficult, I found, because it requires they have given the initial condition. So first first write this equation in form of difference equation, apply these initial conditions, and then find out the inverse Z transform. So for 20 marker means this question seems like 30-40 marks, because this question, the part 3 is itself so big. Earlier this question means part C only used to come for 20 marks. Now they have written 3 questions in it. Okay, so let's try 4A 1. Z is equal to Z inverse minus 1 by 2 Z minus 1 minus Z inverse plus 2 by 9 Z. So we will do the partial fraction. Let's first write it in form of multiply it by Z square. So Z minus 1 by 2 upon Z square minus Z plus 2 by 9. So this will break like Z square minus 1 by 3 square plus 1 by 3 minus 2 by 3 2Z plus 2 by 9. So that will be okay. No, that will not be okay. By 3 1 by 3 plus 2 by 3, and let's take the minus outside, then it will be okay. So Z minus 1 by 2 upon Z minus 1 by 3 to Z into 2 by 3 into I think I am making some mistake. Okay, minus 2 by 3 plus 1 by 3. Z minus 1 by 2 upon Z minus 1 by 3 into Z minus 2 by 3. Or let's write in form of
Addition and subtraction of 1 by 4 will then we can manipulate. It will come Z minus half whole square minus 1 by 36. I'm not wrong.
kindly if you can share it in comment box like Priya did, so that will be easy for us.
Okay.
Proceed to next
Join
question.
from laptop. Yeah, sure.
Okay, so I am going by this only, B upon Z minus 2 by 3, and finding out A and B is easy. And this value of A will be equal to limit Z tends to 1 by 2, let Z tends to 1 by 3, and Z minus 1 by 2 upon Z minus 2 by 3. In this way we can find out A easily and B easily, and then we will find out the inverse Z transform of this. So, but the problem with this inverse Z transform, actually with the problem which I encountered is this. We are having A upon Z upon minus 1 by 3. So to find out this, the Z transform, we require A left multiplied by Z inverse. So Z inverse upon 1 minus 1 by 3 Z inverse. Now we know it will be like A into 1 by 3 raised to the power n, U of n minus 1. The answer is coming like this, means a delayed version. So is it okay? We are having this thing. Pulse response, we are having a delayed version. If you can comment on it, then it would be better. I was doubting in the actual exam how this
Then
is
the
coming.
answer will be 1 by 3 n to the power n minus 1, u to the power u n minus 1. Like if you are delaying the signal, because the answer is coming like a z inverse minus, so a upon 1 minus 1 by 3 z inverse is equals to a into 1 by 3 to the power n into
Yeah.
un. And when it comes when it is multiplied by z inverse, then it becomes a into 1 by 3 to the power n minus 1, u of n minus 1.
Right. Yeah.
However,
So,
I have not solved this question in the exam, so I'm not sure is it correct or not.
yeah. Okay, so this is coming like this, and similarly, the other part is also coming like this. And the part B, the second part of this question is now saying that find out the step response. So what we require to do is by Z is equal to HZ into 1 upon 1 minus Z inverse. And this is becoming even more difficult to do it by partial fraction, because we will then require the 3 terms. The third part is like they are asking us to find the step response with initial condition by Z is equal to by of minus 1 is equal to 1, by of minus 2 is equal to 2. So we require to find first the difference equation. I left it because I was finding it too difficult to do difference equation, and then difference equation needs to be solved by and be required to keep the initial condition and then find the Z transform on both sides, and then we require to solve it. So it was becoming too difficult. If somebody can solve it, means outside, so kindly share it in the group, means which we will form. Now, shall we move to the second part? Yeah.
Yes.
Yeah. So this question, the part is that it is having two parts. The first part is they have given. The first part is 4B. Yeah. So this circuit is given, and they are saying that verify by determining the logic equation for output and by constructing the truth table for the logic circuit shown in figure 4B. Actually, in the actual exam, I found it difficult and I couldn't solve it. I had to leave it. But after just when I came outside exam, and I found it a very easy question. And in this question, left mark it by like write it here. This is I1, I2, I3, I4, and this. And we have to write this by will be equal to I1 F2 F1 var means 0 0. So I1 will be selected. Then I2 will be selected like F2 var F1. I3 will be selected like F2 F1 var, and I4 will be like F2 F1. This way this by will come out, and then I1 I2 we have to write I1 is equal to D0 F0 var plus D1 F0. I1 will be like this. I2 will be equal to D2 F0 bar plus D3 F0. So likewise, we have to go, and then after writing this logic equation, we have to verify it for output. Then we have to write also the truth table of it. So truth table will be like we have to write D0 to D7, and for each value, so it will be too big. Okay, we have to write F0, F1, F2, and for 3 values we have to write.
S0, S1, S2 will be the inputs, and so there will be 8 conditions, I think, like that we have to do.
F0, F1, F2, and by. So again,
By is the
okay,
output.
yeah. So okay, so output will be obviously in terms of D0, D1, like that.
Yes.
Okay, so this we have to do in this question. This seems easy, but in the exam hall, I found it difficult. And when actually the part 2 was very easy, but because of my basic instinct that whenever I see this, I go for outrightly writing the K map, and I wasted about around 15 minutes in this question by making the K map, and the K map was of no use in this question. And the part 2, I made 5 variable K map and wasted around 15 minutes in this question. Okay, so the part 2 I am solving. 8 to using an 8x1 multiplexer and logic gates to implement the following function. Function is required to be solved using 8x1 multiplexer. So this question is easy if we go through, if we first make the truth table. So the truth table will be of 32 elements, 31 elements. And when we make the truth table, then this question become very, very easy. So I'm not going to make the truth table, just writing it A, B, C, D, E, and output. So we will require to write 25 elements. So M is 0. So this is output F. So for 0 it is 1. It is for 1 it is 1. 2 also it is 1.
I have there are some the midterms which are not there, like 3, but 8, 9, 10 is also not there. How, and in the between, how will we figure out that which are there and which of them are there? I mean, is it like those dots? That means that 21 to 28, all of them are present.
I don't think so. I think
This is not a logic series or something, because 3 is
I
not there.
took it
Then
that
again,
way
8.
only, like 21 to 28. I took it that way because
Okay.
otherwise they could have written 20, 21, 28, 29, 30, 31. Why they have written like 21 dash 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 to 28?
so
Yeah,
we
I
need
think that could be given.
we require to take 22, 23 also.
That's what. That's how
We'll,
I took it
we
because
we will
otherwise
take
I
all
would have
21
like.
to 28.
Okay,
That's how I took it.
right.
Okay.
Okay, so I think then I think you both have gone through this truth table method by writing the truth table and then for finding out the F.
The only thing was that it was very lengthy question.
Yeah, actually, I made the K map, and when I saw that already 2 page had filled, and I went out. When I realized
Yeah,
that truth
yeah.
table has to be made, then
I
space was already gone.
according to me, I think the fourth question we should leave in the exam, because if for A part, fourth
Yeah.
A already lengthy question, fourth B also lengthy,
Very
and
lengthy,
the
yeah.
fourth C is derivation, again derivation.
Yeah, 4C is comparatively easy. I think actually
Easy,
only
but we have to write, if you want to get 50 marks, then we should select another question, selecting for
Yeah.
this question, because it is lengthy
It's,
question for A,
it's
B, C, or
all were lengthy. Yeah, actually, you are right.
So which one would you have chosen then? Which one did you find the easiest one?
Okay, we will go about this after completing this discussion,
yeah.
which were easy. Yeah. Okay, so now coming to the 4C. I'm leaving the 4B if it is now. 4C. So it is asking us to determine the closed loop gain of inverting amplifier. So we require to find out V out divided by V in. And we can simply use the KCL, the KCL here at node Vx. And also KCL at this node is also required. So we will use the KCL at here, and this node is also required. So we will write the 3 KCL, and using these, we will find out the V out by V in. I think I found it very easy, and the answer came very quickly. Actually, when I saw this question, so I didn't saw this question, the difficulty of this question. I simply saw this, and I thought, okay, this is multiplexer. I know multiplexer very easy. We will do it, and I solve it first. And that was very big mistake because other 2 questions were very difficult. So shall we do it or shall we leave it?
I think we can do it ourselves. So we should proceed
I have
to
to
the
match
next.
the answer. Can you solve it? Because I have
Okay.
attempted this question.
Okay, so let's do it. 4C.
I think this question is a standard example. I think it can be found in the books also. You can
Yeah.
solve it, but I have
Yeah.
seen it. Yes.
So let's do it. The KCL at node Vx. Vx upon R4 plus Vx minus V out upon R1 plus Vx minus 0 upon R3 is equal to 0. First. Second is, and let's find the KCL at the inverting terminal. So minus V in upon R2 plus Vx upon R3 equal to 0. And the third is KCL at output. So V out minus Bx R1 is equal to 0. Okay. Using these 3 equations, I think it's very easy to solve this V out upon V in, because the third part is simply V out is equal to Vx. So we require to find this.
I just had to match my answer, but I think let's leave it. I'll verify later on.
Right. Okay.
We can
Okay.
solve and put in group, then we can verify. Yes.
Yeah. Yeah. Now coming to the section B. The first question was easy. The step down chopper. Actually, last year they asked so many questions from this buck boost converter and buck boost converter they were asking. Now they have come to chopper, and it was easy question. So let's section B 5A. I'm reading the question. A step down DC chopper is feeding a load R is equal to 10 ohm and L is equal to 20 millihenry. DC supply voltage is 100 volt, and chopper is switching at a frequency of 2 kHz with duty cycle of 50%. Determine the load current and peak to peak ripple current F an absolute value and F a percentage of DC value. Okay. So we will let us first make the step down DC chopper. So step down DC chopper is like this. Here R is 10 ohm and L is 20 millihenry, and it is all across this is output voltage VO. And V input is 100 volt, and chopping frequency is 2 kilohertz, and duty cycle alpha is equal to 50%. So 50% is equal to 1/2. Now the output voltage will be equal to alpha Vs Pn is equal to 1/2 into 100 is equal to 50 volt. are asking us to find the load current. The load current will be V output is equal to average load current. I am assuming they are asking average load current. So V output will be equal to I0 into R. L we will ignore here. So I0 is equal to 50 upon R is 10, so 5 ampere. So the first part is easy. Second part is they are asking the peak to peak ripple current. So I output is like this, and they are asking us to find this value, peak to peak ripple current, delta I. So the if the output voltage is like this, then when it is on, so the whole input is coming V in. When it is, so output voltage is 0, this way it is coming. So let's consider the on cycle, 0 to T on. So in on cycle, the freewheeling diode is not present. So V in is equal to R I plus L di by dt. So let us consider the on cycle. So Bi is equal to IR plus L delta I upon T on. And using this, we know T on, we can easily find out the T on, because T on we can we found out from this, alpha is equal to T on upon T. Frequency is given, so T on can be found out. And from this equation, we can find out the peak to peak ripple current, which is delta I. So is it good? Is it okay? Anybody comment? Is it okay, or we can do by something any other method?
I think it is fine.
Okay, so now let's move to the part B of the question. This is also easy question. 10 10 this is power 8t minus 2x. The material is given and the magnetic field intensity is given. They are asking us to find the displacement current density. So displacement current density is del cross H is equal to J plus d upon del T. This is conduction current density. This is displacement current density. If sigma is given 0, sigma is equal to 0. So displacement current density will be simply del D upon del T will be equal to del cross H. And we need to find this del cross H. So we will write I J K del upon del X, del upon del Y, del upon del Z. And H is given here at Z. So here we will have this H, this is 0, this is 0. And also the wave is traveling in X direction. So we'll have this value also 0 and this value also 0. So the displacement current density will be del H upon del X equal to displacement current density. We will differentiate it with respect to X to find out the displacement current density. The second part is electric field intensity. Electric field intensity can be easily found out by dividing, means the we know the E upon H is equal to eta. Upon H is equal to eta. Eta we can find out from this these two values, where mu r and this epsilon 0 and mu 0 have their usual values. And this okay, it is not given. Mu r and epsilon r are not given here. So we require to find these two values.
Yeah, that was the trick in this question. Like I couldn't
Yeah.
calculate epsilon r and mu r.
Yeah. So that required to be found out from this this equation H. So B are given from the H, it is given that omega is equal to 10 raised to power 8. Beta is equal to 2. And so we know B phase is equal to omega upon beta. And from this we can find out the value of 1 upon the root mu r into epsilon r into 3 into 10 raised to power 8. This value we can find out. Okay. Still we require actually eta.
Yeah, so from here you will get root mu r into epsilon r is equals to 36.
Yeah. But that will not serve our purpose.
Because we need mu r upon epsilon r.
We require mu r upon epsilon r. Okay. Thought I did this question, means I don't know how I did. Okay, so I think we will come back to it later on. Let's leave it. Only because the problem here we are facing is we are not able to find this under root mu r upon epsilon r. Okay. This question I have never heard of this kind of transformer, Scott connected transformer. So if I saw this is Scott connected, I didn't bother to even read this question, and I have not read it even now also, so I'm leaving it. If anybody has the solution of this question, so kindly they may discuss it.
Actually, this is there, but even I don't know. But this it is used to I think convert 3-phase into balance 2-phase supply. I think.
Yeah,
Scott
3-phase into 2-phase supply.
Okay, yeah,
yes.
right. You're right, yeah.
It I think it hasn't been asked earlier, so it was kind of different from the earlier ones.
Okay.
We can solve it like using the the theory which is there, but I think we'll have to revise that. Even I have not read that till now.
Yeah.
Excuse me, sir.
Yeah.
A previous question to find out E bar, that is electric field intensity.
Yeah.
We can use that Maxwell's equation, right? Del bar cross E bar is equal to minus del by del T del B bar by del T.
Yeah.
Actually, I didn't see what. Actually, I
In that
went off
case
this.
also you will need mu r. Because if you are writing del v by del t, then it becomes mu into del h by del t, and there you have not given the mu.
Okay.
Yeah. Okay, so now moving to the part D, 1D. So this is easy question. This has been repeatedly asked in 2018 also. They asked the same question. Transmitter with a 10 kilowatt carrier transmit 11.2 kilowatt when modulated with single carrier wave. Find the modulation index. So let's do the first part. The first part will be, we know the formula for AM. The power, the signal, okay, so signal power is equal to the total AM power is equal to PC into 1 plus M square by 2. And this PC is the carrier power, M is the modulation index. So they have written that 10 kilowatt carriers, the carrier power is given, the total power is given, in modulation index they are asking. So this is very easy formula based question. The second is, if the carrier is simultaneously modulated with two other sine wave also at 50% modulation, calculate the total power transmitted. So in this case, we will require this new value we will require to find PAM into 1 plus this new modulation index will be equal to the root M1 square plus M2 square, and M new whole square divided by 2 will be the new carrier power. Is it okay? It is very easy question. So now let's move to the question number 1E. Move to this question 1E. Okay. So this 1E, this question it is written for the circuit in this figure. EC0 plus is equal to 2 volt and I0 plus is equal to 2 by 3 ampere. Calculate the value of VCT for t is greater than 0. So VC0 plus is given 2 volt. So VCT is equal to, we know, 1E I am discussing. VCT is equal to minus infinity to t upon c integral it dt. So 1 upon c integral minus infinity to 0 it dt integral 1 by c 0 to t it dt. Given VC0 plus is equal to volt, so we will add simply this 2 volt and 1 upon c integral 0 to t. I of 0 plus it is written 2 by 3. I of 0 plus it is written 2 by 3. So actually the current so capacitor is this value plus this value and they both have to be added. It will be 3 by 2.
I think we should it would be better to do it by Laplace transform, or
Actually I thought of doing that, but then I realized that I don't know if you can solve it by Laplace transform, that will be also better.
because initial condition that gives better that is easier to incorporate these initial conditions which have been there in that in the Laplace transform equivalent circuit.
Yeah,
and
actually,
then I think we can convert it back. Yeah, inverse Laplace we have to take.
that is doable actually. Yeah. So okay, if you can do it, then kindly share it later on in the group. What I did in the exam, I am just sharing that. I did.
Okay.
I just added this value and this 3 by 2 I et, and the feed given I0 plus is 2 by 2.3 ampere is given. So I just added and found out the simple calculation. We simple this integration,
Okay.
and I did it. Priya did it. So Priya, how you approach this question?
Actually, I didn't attempt this question. I mismanaged my time, so I had to leave it. I found it lengthy.
Okay. Yeah, actually, if we go through that Laplace method, so that had become very difficult because that required the Laplace.
I did the same thing. So I was doing the same thing, and I somehow stuck in between and realized I left of till times. Have
Right. Yeah. Okay. So that's done with the part and the question, the fifth question. Now coming to the question number 6.
Can you show this fifth E again? I couldn't understand what you have done. Just one.
Yeah.
1 minute it will take.
Yeah. So in 1E, I simply found out the integration across the integration of current across the capacitor, and VC0 plus is given 2 volt, and I found out the from 0 to t it, and that is equal to 3 by 2 I, and I is equal to 2 by 3. It is given 2 by 3 I0 plus, and I simply added it.
2 by 3. Can you repeat this I part again?
Yeah, this till
What
0
did you take? How? What was your value of I?
I is 2/3. I, it is given in a question already. It is given I is equal to. Okay, it is gone. Minute. Yeah. So in this question already. Okay, it is not, yeah, it is now coming. So in this question, I 0 plus is already given.
Yes.
2/3 ampere. And I simply found out the integration of this current and this current. These both will add, so it will be 3/2I across this capacitor. And I have integrated this 3/2I 1/c integral 0 to t dt. So I is 2/3 given here, and I have calculated this integration and added the value of 2 to find the value of VCT at t is greater than 0.
Somehow I'm not getting it. So I'll discuss it later on the group, I think, probably, because somehow I'm not getting it.
Yeah, okay.
Yeah.
Okay, so now let's come to the question number 6A. This question, it is written, is for 20 marks. It is written magnetic field intensity of a linearly polarized uniform plane wave propagating in bi-direction in seawater is this value. So the value given here, perhaps it is at y is equal to 0. And this pi/3, actually I thought it is, they have forgot to write by, but it is not so as far as I now realize. It is actually a phase value, offset phase, which is given here pi/3. And beta value, it is not available here in this question. So beta we will require to find. And okay, let's see then. The attenuation constant is, they are asking intrinsic impedance, they are asking wavelength, they are asking skin depth, they are asking. So let's approach one by one. First, the keyword here is that it is propagating in seawater. So let's first find out the sigma upon omega epsilon to find out whether it is a good conductor or a good dielectric. Actually, I found, seawater, generally we think seawater is a good conductor. But when I found out sigma upon omega epsilon, so the sigma is 4, omega is given here 10 raised to the power 10, and epsilon is 80 cross 8 cross 85 into 10 raised to the power minus 12, right? So the value which is coming is greater than 1. I am not having calculator, so if somebody can find it out, then it's better. But
sorry to interrupt. Actually, the value is 10. You didn't take pi in it. 10 raised to power 10 into pi, because that is given. Omega
10
is given 10
yeah,
raised to power 10 pi.
yeah, okay. So the
is
value,
it still coming more than 1?
if it is more than 1, it is
Okay.
better. Actually, if less than 1, it is coming less than 1.
Okay. Yeah, sigma by omega epsilon, then it is if it is greater than 1, then it's a good conductor. Got it.
Yeah, but if actually I tried to check it 2-3 times that why it is coming greater than 1, then I realized that perhaps the frequency is very high, so it is coming less than 1, and this seawater is here acting as a dielectric. Then I solve it for dielectric. So for dielectric, if somebody can cross check it, if it is really less than 1 or it is not. I did it for dielectric.
I'm doing the same. 1 second.
It is more than 1, I guess.
It is more than 1.
No, it's less than 1. It's 1.179, but that is 0.18.
Okay, so it's less than 1. So it's actually dielectric, right?
Yeah.
So I solve it for dielectric. For dielectric, we find gamma is equal to j under root j omega mu into sigma plus j omega epsilon, and we will take out the j omega mu, j omega epsilon into j omega epsilon into sigma upon j omega epsilon plus 1 is equal to j omega under root mu epsilon, and 1 plus, I will go for this binomial expansion only to the first term, so 1 upon 2 omega epsilon. So this alpha will be equal to sigma upon sigma omega under root mu epsilon upon omega epsilon, and beta will be equal to omega under root mu epsilon. From this, I found out this is attenuation constant, this alpha. Sigma is given here. Sigma is given here, mu, omega, everything is given here. So attenuation constant can be found out from this formula, and the phase constant can be found out from this formula. The second is in this part, in it is asking, they are asking the intrinsic impedance. So for dielectric, the intrinsic impedance will be equal to j omega mu upon sigma plus j omega epsilon, and then be required to make the approximation. Otherwise, this problem in itself will become very difficult. So I took the approximation. What I did, j omega mu, I took out j omega epsilon, right? 1 plus sigma upon j omega epsilon. I found out this value, this is less than 1. Why I neglected it. Accordingly, I found out under root intrinsic impedance is equal to under root mu upon epsilon. And because these two values are given, so intrinsic impedance is easy to find. The third part here is they are asking the wavelength. But if I have made a mistake in calculating the wavelength, because I took this pi by 3 as beta, but it is not beta, because beta is not given itself in this question. It is a offset phase. So wavelength, perhaps what I think, I have calculated this wavelength from this pi by 3. So I took beta is equal to pi by 3, and accordingly, if beta is equal to 2 pi by lambda, and I found out this, perhaps my wavelength is wrong. Wavelength will be, actually the wavelength will be, we know the phase velocity we know, under root mu upon epsilon, and omega also we know, 10 raised to the power 10. From this we require to find out the wavelength lambda. The fourth part here is skin depth. So skin depth will be simply equal to 1 upon alpha, attenuation constant. Okay. Now coming to the part 2 of this question. Fix 2. Here it is written, location at which the amplitude of H is 0.01 ampere per meter. So the location, what I thought about this question, because the H is given equal to 0.1 sine 10 raised to the power 10 t minus beta. This is traveling in bi-direction, so bi minus pi by 3. This is actually the this equation. So if we can write it in form of phasor, omega t we can remove. H will be the phasor will be 0.1 e raised to the power minus pi by 3. We have to take the because the real, here we are taking like H is equal to imaginary part of phasor, e raised to the power j omega t. Real part, actually imaginary part, because the sign is given here. So H is equal to e raised 0.1 e raised to power minus pi by 3 into Priya, can you kindly just mute your, yeah. So this Udit, can you mute your this microphone? Okay, so this H is equal to 0.1 e raised to power minus pi by 3 to I am writing the phasor of this equation here. E raised to power minus beta I. This will be the phasor, or if it is correct, this is the value of H0. Now, what they are saying that at what value, and okay, we have to take the alpha also, e raised to power minus alpha x, j beta y. So H0 will be equal to, they are saying at what location the magnitude will be 0.01. So 0.01 is equal to 0.1 raised to power minus pi by 3. Here it will be j. So we are not required to take it into e raised to power
Priyank, I
minus.
have one doubt. Yeah,
Yeah,
that
yeah,
J. Yes, yes.
yeah. So this alpha we know, and we require to find this by from this. So it is easy to find out by, because I'm not taking this j because this is in j form. This is offset phase. So it is easy. The part 2 is easy. And the part 3 is expression for E by T and H by T. So let's first write H by T. So H by T, we have already written 0.1 e raised to power minus alpha y, fine, raised to power 10 pi t minus beta y minus pi by 3. And they are writing us to, they are asking us to write at by is equal to 0.5 meter. We can write by putting this by value here. And E of yt they are asking us to write. So actually we have to write also these values ax ampere per meter, and here also the values also required because the wave is traveling in by direction and h is in x direction. So we know E cross h is equal to the wave propagation direction. Here wave propagation direction is in y, h is in x. So what will be value of E in which direction it will be? So will be in minus z. It will be in z, not minus z, it will be in z direction. So we require to divide E upon h is eta. So h into eta. So just eta we require to multiply it by eta, and the whole same value will be here, and the direction will be a z volt per meter. Is it okay, or there is any miss? Okay. Okay, so shall I move to the next question? Rajendra ji. Okay, Rajendra ji is not there. Udit, shall I move to the next question?
Yes, I think please. Actually, I have not
Yeah.
revised this from a long time, so I was not involved. Yes,
Okay.
please move to the next question.
Right, yeah. Okay, so the next question, actually the inverter is coming now, and they have made an inverter here. This is inverter. Actually, this inverter question, I thought they will not ask because series inverter they asked in 2019, and generally before that they were asking only H bridge inverter, which is easy, and generally everybody read the H bridge inverter. But now instead of one phase, they are now asking 3-phase H bridge inverter. And seeing this, I think now in future they may also have the parallel inverter, because series inverter they have asked. Now only parallel inverter is remaining in that chapter. So it's quite possible now that parallel inverter may also come. So here the question is a three-phase bridge inverter is shown here in this figure, and it is feeding a star connected resistive load with R is equal to 10 ohm per phase. The DC input to the inverter VF is 400 volt and the output frequency is 50 Hz. If inverter is operating in 180 degree conduction mode, compute the RMS value of load current. The second part is this question has been directly picked from PF Bhimra. It is a solving example of PF Bhimra. The second part of this question is compute the RMS value of current in the each switching device. So shall I solve it?
I think
I
if
have
it is
not
directly
solved
given,
in the exam, so you cannot have.
Can you repeat? Yeah.
You can touch over these points, the formulas.
Yeah.
Waveforms,
Okay. Yeah.
that
Actually,
solution we can do.
Yeah. Actually, I am from electronics communication discipline, so earlier I used to find a little difficulty in doing these things, but now I have. Okay. So we will discuss it. Okay. So the H bridge inverter is there. In H bridge inverter, what we require and this H three-phase inverter, and there are two conduction mode in it. One is the 120 degree conduction mode, and other is 180 degree conduction. This year they have asked from 180 degree conduction mode. 180 degree conduction mode, actually we have the this is simply, if we say, it is opposite of this phase control rectifier. So we have a diode here. This diode, not diode, actually the switch is there, Q1. Second switch is Q4. And again the switch is Q3. Second switch is Q6. Third switch is Q5. Second switch is now they are having the star connected load. Now actually what is there, that these switches are being fired in a particular sequence, so only we are getting a output here. Let's say it is a phase A, this is phase B, and this is phase C, and this is neutral. So if these SCRs are fired in a particular sequence, then only we will get an output which is a kind of sine wave, not exactly, but a kind of sine wave. So in 180 degree conduction mode, a firing sequence is important to remember. So how to remember that firing sequence in 120 degree conduction mode? 180 degree conduction mode. We will make a kind of table. We will divide this table in three parts. So let's start with 0. And every division is of 60 degree. So 60, 120 degree, 180 degree, 240 degree, 60 degree. When 360 degree has been completed, so again the 60 starts, and 120, 180. And each switch is conducting for 180 degree angle. Okay. So let's start with this. Actually, we have to, this sequence is fixed, and the firing sequence is fixed. And the sequence is also important. Q1, Q4, Q3, Q6, Q5, Q2. These switches are connected like this. So at 60 degree, T2 is fired. This thing is required to be remembered, otherwise we will not be able to solve it. So at 60 degree, T2 is fired. Now at 120 degree, T3 is fired. And T3 is fired for 180 degree, means 180 degree conduction mode. T2 is also fired for 180 degree. So T3 will run till here. At next 180 degree, T4 is fired. And it will also carry for 180 degree. For 180 degree, 180 to 180, it will be 360. Okay. I have missed actually. Here it will be 300. And here it will be 360. And this will be 60. And this will be 120. So till here it will be T4. T2, T3, T4. Now again T5 will start from bottom. And T5 will be fired at 240 degree. And it will run for 180 degree. So 240 to 180, it will be 60 here. T5. Now T6 is fired here at 300 degree. So T6, it will also run for 120 degree angle. So 300, it will run till here, T6. And actually we have only 6. So here it will be T1 finally. Right. And if we see the sequence, so in the third we are having only T2, T5. In second we are having T3, T6. In first we are having T4, T1. Right. So here it will be T1. Here it will be T3. Here it will be T5. So in this way, this conduction is happening. This is important because in 120 degree there is slight difference. In 120 degree conduction mode, there is a little difference. Like each this switch is actually conducting only for 20 degrees. I mean for 120 degrees. So for T2 we are having 60 to 180, and this left is not. This is no switch is conducting in this mode 180 to 240 means T2 is not conducting. T3 and T4 will still conduct, but not T2. Likewise, everywhere we have to reduce by 60 degree. Okay, so this is how it is. So if we see, if we talk about 120 degree conduction mode, so from 0 to 60 degree, we are having only T5 and T1 into conduction. 60 to 120 we are having only T2 and T1 into conduction. 120 to 180 we are having, this is not available, T3 and T1 in T3 and T2 into conduction, right? Now we have to plot the output phase voltage. Okay, okay, now, oh yeah. So now we have to plot the output phase voltage at across terminal A for 180 degree conduction mode. So for 180 degree conduction mode, let's draw the diagram again. 180 degree conduction mode. From 0 to 60. 0 to 60 degree, which diodes are, which switches are conducting? T5, T3 and T1. I have modified this diagram for 120 degree. For 180, we will not having this thing. Means 120 for 180 degree, we will be having this full. For 120, we will be having this def. For 180, we are having this full. So for 180 degree conduction mode, from 0 to 60 degree, the 3 switches are conducting T5, T3 and T1. Right. So let's draw the diagram. Redraw the diagram. 3 T5, T3, T1. T5, 3 and T1. These three are actually conducting for 0 to 50. So ultimately, the phase voltage output will be, for this case, will be equal to for 0 to 60 degree, it will be like this, right? BF. For 60 to 120, it will be 2 BF. And from 120 to 180 will be again BF. This way. And now for this, this is phase voltage. Means either it is VA or VV, it is phase voltage. Obviously, VB will be shifted version of by 120 degree. VB will be shifted. I am plotting it for VA, and it will be like this. So this will be complete. The cycle will complete. The phase voltage, the cycle will complete like this. Now in question they are asking, what they are asking? They are asking us to compute the RMS value of load current. So output phase voltage is this, and this can be used to find out the output load current. IU will be nothing but V0 divided by R in this case, because we are having the resistive load only. So the load current will be same, means it will be same like VO only divided by R. Now what is required? We require to find out the RMS value of load current. So what will be the RMS value of load current? So from this curve we require the RMS value. So the RMS value will be equal to shall I leave it or shall I go into it?
I think we have everyone has got the idea now. You can proceed to
You
the
can
next
leave
one.
it, sir. Easy.
Because
Yeah.
it's there in the book also. Yeah.
Yeah, it is directly available in BF Vimra. This question is directly available.
Ah,
Yeah.
yes, it is there.
Yeah.
All
Okay,
the
so
parts of it are there. Yeah.
actually, if too much time taken, if you have not read before the exam, you will not. It's very difficult to solve it in the exam.
Yes.
Now let's come to the question number 6C. So it is very easy question 6C.
Yeah. Again, it is.
It's a simple integration, and using this integration, we require to find out the value of K, and then we require to find out the probability that random error in the measurement is less than 1/2. So less than 1/2, then that will be
Minus
equal to,
infinity to 1/2. We will integrate
yeah,
minus infinity to 1/2.
yeah, minus infinity to 1/2 fx dx, right?
Yes.
Yeah, and first part can be found out from f integral minus infinity to infinity fx
Equal to
x is equal to 1,
1.
right? Yeah. So this completes our question number 6. The 7th question is again the ABC parts are there. So let's discuss. The 7th question is actually important because the second part is important. First part is little bit difficult because these such kind of question has not been asked earlier. 7A. In 7A, it is written that
They asked similar question in 2019 also.
similar question. Yeah, you are right. Similar question came in 2019. So, okay, shall we do it?
We can skip it.
Okay. Okay.
You solved it in the exam? This one.
No, not actually. After exam, I didn't attempt this question in the exam.
This is too much time consuming.
Yeah, actually, if time consuming question. So if If you want, then actually I have studied it after coming back from exam and I have revised it. So if you want, then we can discuss it. Otherwise, we will leave it.
Okay, then we will see at last.
Okay, right. So 7B, simple question, which is about three-phase full wave. Okay, so my question is not clearly visible now. Three-phase full wave thyristor bridge converter is operated from a three-phase star connected 220 volt 50 Hz supply and the load resistance is 20 ohm. It is required to calculate the average output voltage of 50% of maximum possible output voltage. Determine the following the delay angle. So do I require to discuss it because it is also directly from PS Mimra?
Yeah, it is
Again,
directly formula based.
If you want, then we will discuss because this is easy question and repeatedly such questions are being asked. Or we will leave it.
I think we can move to the next one because
Okay.
all of it is based on formulas only.
Right. Yeah, it is based on formula only. The third question is very easy. Means like seeing only we can find out the reflection coefficient ZL minus Z0 upon ZL plus Z0. Standing wave ratio is 1 plus reflection coefficient upon 1 minus reflection coefficient, and input impedance is also easy to find. So the third part is very easy. So this also we can skip.
Attempting question 7 was rewarding compared to questions of part 1.
Question 7 was rewarding. Actually, if you know this synchronous machine, then it's rewarding. Because the second part is easy and the part B is easy, part C is also very easy. But this question, but I think not everybody would have read this ER gap line, modified ER gap line, saturated and unsaturated value of synchronous reactance. Anyways, okay, so now let's move to the question number 8.
Sir, excuse me. Sir.
Yeah.
So that previous question.
Yeah.
Three-phase full wave rectifier bridge.
Yeah.
Can you write that equation? How to start? Like they have asked, it is required to obtain an average output voltage of 50% of maximum possible output voltage. So what will be that maximum possible output voltage here?
Yeah. Okay. So three-phase bridge rectifier, I'm just writing formula. Here only not only average voltage we require RMS voltage also. And RMS voltage actually you cannot remember the formula of RMS voltage. It is actually required to be found out in the actual exam. So the average voltage is, we all know average voltage is equal to 3 VML upon pi alpha. The question is asking, it is required to obtain the average output voltage 50% of maximum output voltage. So the maximum output voltage will be when cos alpha is 1. So V output average max equal to 3 VML upon pi. Now it is saying that find out the alpha. So let's say that is alpha dash. So that will be 50%. So 3 VML upon 2 pi equal to 3 VML upon pi cos alpha. This alpha value we require to find out in the first part. The second part is difficult because it is saying RMS and average value of output current. RMS and average. Average we can find out very easily because it is we are assuming it is a CCM, continuous conduction mode. So this B output will be equal to I output into R. And this load is actually what is resistance is 20 ohm. So I0 is will be simply will be equal to B0 Average, it is average. I0
the
average.
CCM assumption I think will not hold because the load is a resistive load, so continuous conduction mode will not happen. We will
No,
have to make
for if you go through this analysis is given in PF Vibra very clearly. For three phase
okay.
converter, resistive load for alpha is less than 60 degree. We always have CCM.
Okay.
And
Okay.
for alpha greater than 60 degree, we have DCM. Right.
So alpha here is 60 degree. It's at the verge of. It's at the verge of. It's 60 degree now because
you have
is
found out
760.
alpha. You have found out alpha.
Because
Yeah. Cos alpha is
is
equal
half
to
now. So yeah.
alpha is half. So we can assume it's CCM. If we take it at DCM, then it is means it's beyond our reach to even discuss this question.
We can make that. We have to. I think we'll have to make the waveform, and then it will be. We will be able to solve like that both of those RMS and average from the waveform.
But for DCM, actually, for CCM only, the waveform is so difficult. How DCM you will make the waveform?
I don't think it is DCM actually. It is at the verge of CCM, like CCM, because it is at 60 degree now. So when it will be greater than less than 60 degree, I think then it will be DCM. So it is still, it will only touch the horizontal axis. It will not go to zero. It will be only for in that instant. So we can still find out.
Yeah.
I think.
Okay, so waveform you are saying, so waveform will be like this output voltage.
Waveform, I think. Yeah, we have
actually
to draw the.
There is no, in my opinion, there is no option rather than means only option is you should simply know from where to where it runs, because in actual exam we don't have time to make waveform, think about waveform from where to where it will go. So so the easy option is actually I remembered and I learned it. I remembered it. This output voltage here in this three-phase converter is running from 60 to 120 degree, and it is repeating from 60 to 120 degree. Okay. So B output RMS we require to find out. B output average we always require, we remember, but B output RMS we require to find out. So that will be equal to 3 upon pi alpha plus 60, alpha plus 120, and B ML square sine omega t d of omega t. So this integral we require to find out, and then after solving this integral, we require to find out V output RMS, and from that, I output RMS will be equal to V output RMS divided by R. So actually, I think there is no other option only to lose these 2, 3, 4 marks, because nobody is going to solve this difficult integral and then finding it out. The third part is comparatively easy if we remember it. Again, the thyristor current formula we require to remember. So the third part is RMS value of thyristor current. And it is equal to, for almost every case we have, I0 upon under root 3 for three phase. Whether it is in case of half phase, means 3 pulse rectifier or 6 pulse, it is always it is same. For one phase also it is same, I0 upon under root 2, we have the RMS value of thyristor current. Average value of thyristor current we have I0 upon 2. Here in this case, average value becomes I0 upon 3. So if we can remember it, and then only we can get the third question. The fourth part here is rectification efficiency. So rectification efficiency is actually eta is equal to V output RMS to I output RMS upon V output DC into I output DC. For DC value we have, RMS value we have, and we require to put these values into it. Generally, if we see B output RMS upon BI, okay, it will not solve like that. We require to put the values only. The fifth part is input power factor. That is equal to B output RMS into I output RMS under root 3 BF into IF RMS. Now, this thing comes, this IF RMS. What will be the value of IF RMS? Source value, source current RMS value. So the easy option here, in my opinion, is actually its value is I0 under root 2 by 3 if we assume CCM. So I source RMS is equal to I0 under root 2 by 3. As far as I remember, this value is there. Needs to be verified, and accordingly it will fall. Okay, so shall we move to the next question number 8?
Yes.
Okay.
Yeah. Question number 8. The first question is coming directly from BP Lathi. It is an unsolved problem in BP Lathi. And the question is actually, I think what their pattern is. 1 year they are asking from Simon Hacking, and another year they are asking from BP Lathi. So alternatively they are asking. Last year they asked a direct question on FM communication from Simon Hacking. That was unsolved question. This year they have asked us an unsolved question from BP Lathi. It's not an easy question as far as I think. Question is, shall I require to discuss it?
Yeah, yes, please.
Yeah. So here the question is, for an FM communication system with beta is equal to 2 and wide channel noise with power spectral density Fn omega is equal to 10 to the power minus 10. The output FNR is found out to be 28 dB. The base signal MT is Gaussian, band limited to 15 kHz. And 3 sigma loading, this is a new term. 3 sigma loading is used. Now, question is, determine the following: the receive signal power Si, the output signal power F0, and the output noise power N0. Okay. So the FM communication system, briefly I am drawing. Receiver is, we are having receiver FINI, and this is FM receiver F0 N0. One formula which is commonly used and repeatedly has been asked by UPSC as well is F0 upon N0 is equal to 3 beta square gamma M square T on MP square. This formula is directly available in BP Lathi. Actually, they have gone through a very tedious derivation of this formula, where beta we know, this gamma is actually baseband value. So baseband we know, baseband gamma is equal to Fi upon B. N is this power spectral density, and B, and M square T is the power of signal, power of baseband signal. MP square is actually peak value of signal. Peak value of signal. Right. Now, the important thing here is they have written 3 sigma loading. So the 3 sigma loading here is this MP is equal to 3 sigma. Right? And M is equal to sigma. Therefore, we require to put these things into the formula. 3 beta square gamma sigma square upon 3 sigma ka whole square. Now F0 and F0 upon N0 is given, which is equal to 28 dB. We require to convert it into actual value. We are required to convert it, and from it we can find out this gamma. And the gamma is equal to gamma. We will find out some value of gamma, and the gamma is equal to Fi upon Nb. Now we know this n is given. Eta by 2 is given. It is given that eta by 2 is given 10 to the power minus 10. Bandwidth is also given. Bandwidth is given 15 kilohertz for Gaussian signal. So we can find out the input signal power. Part 1 will be solved. We will solve like this. And the other part is, shall I solve the other parts as well or not?
No problem, sir. Sir, you were able to solve this in exam?
Not actually. I have not attempted this question. After coming from exam, I have solved it. If you find it difficulty in solving it, then you can discuss it with me personally, because I have read this BP Lati very seriously. So I know from BP Lati questions, if they come, then I will be able to solve them. So the questions which are coming from BP Lati or Simon Hacken. So if you find difficulty in solving it, then we will discuss it separately as well.
Which book to follow actually?
Actually, going by pattern, I think for next year, one question is coming on FM from Simon Hacken. Unsolved question they will ask from Simon Hacken, because this pattern means they are repeating questions, means alternately they are following. 1 year they are asking from Hacken, 1 year they are asking from Lati. So this year they ask from Lati, next year probably they will ask from Hacken.
So I think it will be very time consuming to solve all the unsolved problems from the.
Actually, yeah, it is time consuming, but I think it is best way if we similarly like what we are doing today. Someday you read and we will discuss those questions, because if we sit in isolation and we start solving, we get distracted, right? So if we make a group and we will discuss like some other day, if you read the BP Lati and let's discuss those questions. So we will discuss one by one each question of BP Lati, backside question. You read it and I will also read it, and then we will discuss. That will be good way.
That will be better.
Yeah.
It will be better. We will be able to concentrate also, and we can help each other also, because like I am from electrical, so this is non-core subject. So again, I don't understand this that much. Don't have that much understanding. So it would be better to discuss in group, and so that to gain some understanding.
Right. Yeah. So that would be, if we 4 or 5 people are there, that is enough actually. We can make a small. Yeah. So so if you have not read this FM communication from BP Lati, then it's very difficult to understand even this question. So I would suggest let's first read it and then we will discuss.
Yes.
Yeah. So this 8B, the question number 8B is, this question is easy. The 3-phase induction motor they have asked. And shall I read it and do it or not? 3-phase induction motor question.
Yeah, I think this
I
question
think it will be. It is solvable by that equivalent circuit, na? We have to draw equivalent circuit and
through equivalent circuit we can solve it. But I would request if Udit or Sachin, if you can solve it and if you can share it in a group, then we will be also able to discuss it. Actually, I have solved it, but if you also.
Sure. I will share. Even I have not revised it right now. Even I am working and preparing, but yeah, I will surely do it. It is doable. Once after revision, we can do it.
Yeah. If directly means, if I think means it's directly that diagram we draw equivalent circuit, and from it is directly coming.
Yeah, it is the direct application.
Yeah. And the third part is also very easy. It is about separately excited DC motor. And we have to find out at rated condition, and then we have to find out it is from electric drive, and it is very easy question. Repeatedly they are asking. So if you want, then we will discuss it or we will leave it.
Okay,
yeah, it can be done, I think, because we will get output voltage of that rectifier, and then we can find the back EMF, and then mechanical power.
Yeah. It is doable. Yeah. So actually now I don't think we are in position to discuss paper 2. So that we
Now
will
to we
keep
can't.
that we'll keep for some other day. And for the time being, let's make a group and 4 or 5 people, and let's plan. Let's make a schedule. Means a 3-day or 4-day schedule, and everybody will read that subject, and then we will sit and solve the problem.
Yeah, it
Yes,
will be
Priyank.
good
That will
if we
be
can.
good. That better.
We can yeah, we can make the schedule, and also we can define a source for it, like what source should we what source should we refer, or is there some book or some PDFs if their short notes are there, so that we can share among ourselves and we can read from that only, and then we can discuss and solve questions. Because
Actually,
we have
as
to
far as
we have to concentrate on GS also now. So yeah, so this also we have to, we have to refer to limited. You must be knowing, you are much more experienced. I have not appeared for mains even once. I am just working and preparing.
Actually, as far as my situation is concerned, I have applied. I am writing this exam in 2014. That was my first mains in 2014. Then questions were very easy. If you feel questions were very easy. Since 2019, the question level has increased. Now they are asking very difficult questions. Some questions are really difficult. From communication side, they are asking difficult. From this power electronics also, they are asking difficult questions. So, but my approach has been that for communication, like we have the BP Lathi and Simon Hacking, there is no substitute or substitute of it. You may go through that some other book, but they will only lead to your time waste. If you want to really solve the problems in the exam, then you require to solve all the problems of BP Lathi and Simon Hacking. That is only what I think that is feasible option. And the same is applicable for this power electronics also. You require to solve the PS Bimra question. For machines, you require to solve that AFPA at least all questions. And this digital electronics, I am relatively I am weaker. So I would ask your suggestion from where we can read the digital electronics. People are suggesting Morris Mano, but I read that Morris Mano in my college time, and actually I have never read this Morris Mano for digital electronics. I have not read anything. So I would ask your suggestion. So from source, if you can suggest. But for communication, I would suggest these 2 books, the BP Lathi and Simon Hacking, and we will make a revision schedule from the chapters of these books only. And for this power electronics is Afpak Hussain is there. This Afpak Hussain and these 2 books are there. And this analog electronics can be done from JB Gupta. That is good book. We will at least cover this JB Gupta in by making the schedule by chapter wise schedules we will make for 3 days or 5 days. So we will revise from that JB Gupta. And this circuit theory and this signals in system, they all require the problem solving. So for signals in system, OpenHAM is better. And previous year questions are always better. So if we make a schedule, so first priority will be our previous year questions only. We will discuss those questions first, and then we will discuss the solve examples of book. Right.
Actually, the problem is prelims is appearing now. I mean, it's approaching now. So I think we have to somehow manage both. It will be at least for those first attempters or second attempters, it is going to be difficult.
Yeah, actually that's true. Okay, so actually I am also not for 100%. I have to I am sitting in my office currently, and I do office in morning 10 to 5, 6, and then I start study. So I also don't have much time to study. But whatever is possible, whatever is feasible, we will do.
So, but your story is so inspiring that how you are able to manage both your job also and for the exam preparation, and it's great that you have appeared till interview twice.
Yeah, actually, but I am not able to actually, since so long I am studying, but still there are a lot of things which we actually not able to revise at the time of exam. We forget at the time of exam. This happens actually. We read everything and we forget it. By the time exam comes, we forget. So this is the problem. Anyway, we will make group and we will then discuss. Right.
So, last one question.
Yeah.
Sir, like, how many marks should we attempt for so that we get decent mark? Like how much correct attempt it should be? From your
Actually,
experience, you said you got 286 marks, right? So what
yeah.
was your correct attempt that time? How many marks you got?
Actually, at that time, paper was easy. Comparatively, since 2018, paper were easy. If you see the pattern, since 2019, paper has become difficult, and even 286 is very high marks. In 2020 or 2019, the 286 are very high marks. So, earlier into 2017, if you see someone got 350 marks, that Rufikesh Reddy from that Hyderabad, that person got 350 marks in electrical engineering.
Yeah, that too. He attempted for 400 marks. He said. So,
Yeah.
what was your sir? You attempted for how many marks and you got 286?
Actually, you just multiply by 0.75, that will be your score. If you attempt for 400 marks, if correctly, I am saying, if you correctly attempt for 400 marks, so just multiply it by 7.75, that will be your marks.
Okay. So do they give step marks also, or they check only the final answer?
That depends upon examiner to examiner. I think some people give, some people do not give.
Okay, sir. Thank you for your input. Actually,
Yeah.
I have found Anand Kumar very good for digital electronics. Last year,
Yeah, Anand Kumar is a good book. Yes, I also followed that in college. It's good.
Boolean algebra, this derivation was asked directly. It was from Anand Kumar.
Okay, so the questions are directly being asked from Anand Kumar. So okay,
Yes,
so
yes.
this year it would be better if we read that also. Okay.
We can share these books now, PDF we can share in the group, because not we can't purchase every book hard copy. Plus, even during office time, if someone has to study, then it is better that PDF is there, so we can study sometime if some free time is there. So
Yeah, PDFs are available. I have all the books PDF. Generally, I have with almost all books PDF I have. So I will share those PDF, no problem. PDF I will share. I have this next IAS test series also 2018, 2019. So that also I will share.
yeah, it is really valuable then for us.
Yeah.
Your whatever you have collected in this.
Yeah. I will share. No problem. Yeah.
Okay, then
Okay.
Hi, Priyank sir.
Yeah. Hi. Yeah.
Yeah, here I am Nitish. Yeah, I just started preparing for this exam. Okay.
Yeah.
Just I need your input, like how to do for GS and all this part for like primarily qualification. And I am working.
Actually, I am not much into this GF. GF, you can take suggestion from anybody. For electrical optional, I can talk here. So whatever we are discussing for electrical optional, first is you need to read all those standard books, and after reading those standard books, you need to also require to solve all previous year papers and all the questions which are given in as a solve example, at least in the book. All those are required to be solved.
Okay.
Yeah.
Okay. Thanks.
I think
Yeah.
you can even right now. So it is already prelims is approaching, but I have watched some these theatrics videos. Ankit Goyal sir is there. His videos are also good. Like they are good. Explanation is there extensively. They have covered, but it will take time to cover them. But yeah, and he also provides a PDF notes for all those slides which are there in that video. So that is also good. Maybe I don't know how much it covers. Mostly it covers everything, but maybe it is like it can waste time also, because many things are covered. It is from gate point and ESE point of view. So
Yeah, generally that gate point of view and ESE point of view now will not help in the exam, because this exam is now having a set pattern, and when you follow that pattern only, then you will succeed. Otherwise, questions natures are different in a different exam. ESE is almost now completely different. It has become ESE. The ESE has become different.
yeah. So like, can we like conclude that like for solving questions and following those things which are being asked in questions is a better approach rather than just going and studying everything, because that will again it will lead to like it will utilize a lot of time, which will be from I will not be able to study GS and all that much if we put too much time in this. So like doing question based study is better. Or
That is
solving.
all. That is also okay. But if you just like B Pilati, I am saying, if you just go through, if you just have a cursory look on it, like 1-2
Mhm.
time, and you will be able to realize. Then we will discuss it, and then you will get the idea. This power electronics is very easy for someone who is means good in means learning. You know that the ability which is called, if you just memorize the things. So if you are able to
Yeah.
memorize the things, you will be you are going to excel in power electronics, because most of the things formula
Okay.
based are there. So
Mm.
these things you means, if you just read it and we will discuss it, that will be easy for you.
Great. I
Yeah.
think, sir, we should now form a
Yeah.
group and all.
Yeah, we will
can
form.
discuss
Yeah,
the
sure.
second paper maybe on Sunday in the evening only, because after
Yeah,
office
yeah.
only it is
Right,
better.
right. We will discuss. Yeah, yeah. And for the time being, the unsolved problems what we have left, I would request that Udit and this Sachin, if you can solve those problems, then that will be even better if you just solve and share those problems in the group. Yeah.
Mhm.
Yeah. So now let's conclude it. Okay.
If we keep very limited people, yeah, it will be good if we keep limited people only, like 10
It's
people.
4, 5, 6 people. Like Rajendra is there and you are there. Priya is there. So she has already attempted. So she will be of great help to us, because few
Yeah.
things, many things, these aspirants, because we are studying, all are studying in isolation. I have not attempted, I have not taken any coaching notes. I have not attempted any test series. So I don't know what is happening in coaching for any or others are reading. But if we all can collaborate, then we will be a good team.
Yes, yes, sure.
Yes, right, sir.
Right. Yeah.
Uh,
So yeah.
I think when we will be able to, we'll communicate to the present group which is there, and we can make that new group and just stick the number of people. Whoever attended this session, maybe only those people, then it is better.
Yeah, that would be better if you can just kindly. Okay, some echo is happening. Okay, hello. Yeah, if you can just kindly ping me on my this Telegram, and I will add you in the new group. Let's form a new group, and just only limited people we will add in the new group. Okay, so shall we conclude now?
Yes, sir.
Yes, sir, sure.
Yeah, yeah. Okay,
Okay, sir.
thank you. Yeah, thank you. Yeah,
Yes, yes. Yeah.
thank you.
Thank you, sir. Thank you so
Yeah,
much.
yeah.